Good evening, everyone. This is Mr. Taylor with Young Engineers of Today. Hope you all are all having a wonderful Monday and you had a great weekend. Hopefully, you had the opportunity to get outside, enjoy our beautiful weather before it continues to get colder now. Um, but let's get started. If you can hear me, please raise your hand. All right. See Nick, Sam, Taha. What else do we have here? All right, I only got three people. Hello, Katie. I'm doing well. Hope you are too. Okay, Nick, Sam got their hands up. All right. Okay, I'm going to put hands down. If you can see my screen, raise your hand. All right. Katie, Nick, Sam, Taha. Very good. Very good. Majority of the people. Okay. Tonight, we're going to be looking at the history of computing. Since we're going to be moving into uh, the Raspberry Pi, a microcomputer, we're going to look at the history and evolution of how we got to this point, with computers being all around us and the technology having so much advancement over each minute, day, year, that we're going to be looking at how we've gotten to this point and how technology builds on top of itself and how new discoveries help make it better. All right. Go ahead, Sam. You're unmuted.
Hi there, this is Sam's mom. Sorry to bother you.
Hi, how are you?
I'm good, thanks. We had a question about the Raspberry Pi and what we need to get ready for on this end of it.
Okay.
So we don't have, I mean, we just all we have are laptops, and I'm under the impression that's not going to work.
A Raspberry. Can you turn me down a little bit in the background?
Sure.
On a Raspberry Pi, what you will end up needing, and we'll go over this in the in our first class that we use it. You need a monitor of sorts, um, a keyboard, and a mouse.
Okay.
Um,
So laptops won't work, right? We need to
no,
figure out.
because the thing is, a Raspberry Pi actually is a computer.
Okay.
It's a fully functional computer. It's just way cheaper and it runs off of Linux.
Okay.
With that being said, it uses a USB mouse and USB keyboard, which if you have one laying around, great. If you don't, um, they're you can find them. Like
Okay.
I've been able to get a keyboard at like the Goodwill. Just stop by, found one.
Okay.
Um, but we'll be going into more of that next time. The monitor, if you, what type of TV do you have?
I know we have an old one.
Okay. All right. So, about to say, if you had a TV that has HDMI, you can plug it into that.
Yeah. Okay. So should we be ready for this by a week from Wednesday?
Um, it we'll be moving in probably next week. Will be fine. We're gonna be going into like some of the basics probably next class. Uh,
Okay.
an general overview, but nothing real heavy where he would feel like he's behind or anything like that.
Okay.
And then there's
Okay.
always the other the feature of if you don't have it and you need more time, you can always watch the webinars to get caught up as well.
Right. Okay. All right.
Okay.
Thank you so much.
You're welcome. Have a good evening.
Okay.
Okay. Yes, Katie.
We have no desktop in our house. We only have laptops. What do we do?
With regards to what?
We don't. We just have laptops. Me and my brother just have laptops. So, and we want to hook up the Raspberry Pi, but you just said it needs a mouse. So,
You're gonna need a mouse, a keyboard, and something to some form of a display. What
we
type
don't
of
have any of that.
what? Excuse me.
We don't have any of that. We just have a laptop,
Okay.
and I
What
don't
type?
use a mouse.
Do you own a TV?
Yes.
What type of TV is it?
LG TV.
Okay. Does it have HDMI?
Yes.
You can use that as your monitor.
Okay. Thank you.
You're welcome. And Zach, you missed nothing. Don't worry about it. I was just answering some questions. Okay. All right. Now, any other questions regarding Pies, computer ones, or maybe Apple? Okay. Bad joke. Bad joke. Okay. Henry has a question. Yes, Henry.
Wasn't it the what's it called on Saturday? The lab?
Yes, sir.
Is there anything I missed?
Yes. You missed setting up your SD card for your Raspberry Pi.
I think my sister did that.
Yeah, you should be good to go. Your sister
Okay.
can be completely caught up on that.
Okay.
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 All right. Thanks, Henry. Okay. What do you guys know about the history of computers? Would anyone like to share anything that they know? Let's go with Max. Just Max, not Zach and Max. Hey, Max. You're unmuted, Max. Okay. Max, seems we're having a mic issue there. Let's go with Taha. Go ahead, Taha.
I'm muted.
In the olden days, the computer usually took up one whole room.
Okay, computers were huge. This is true. Thank you, Taha. Very good. All right. Anyone else? Try you one more time, Max. All right, Max. We're having some type of connection error there. And anyone else are more welcome to type anything in. All right. Yeah, computers used to be that big. As Taha is 100% correct. Now, let's get started. These are some, just to start off with a little light humor, a few comical jokes about computers. My software never has bugs. It just develops random features. If you don't want to be replaced by a computer, don't act like one. There are 10 types of people in the world, those who understand binary and those who don't. That's a joke, if you understand binary, because it's based off of ones and zeros. Supercomputer, what it sounded like before you bought it. And to err is human. To really file up requires the root password. A few computer jokes for you guys. All right. We're going to start off all the way back into the 1820s with the father of computers, Charles Babbage, on this device called the difference engine. The difference engine was basically a form of a calculator. He designed it, never actually built it, but he worked on all the algorithms, the design features to actually make it, to have it made. Now, by the difference engine 2, this computer was not built until Charles Babbage's 200th birthday in 1991. So way after he was passed away, they built this device, and he designed. And Charles Babbage was an amazing mathematician, and I want you to realize that the computers, programming, etc., is based in mathematics, and all the early programmers, computer engineers, they were brilliant mathematicians. Okay. Now, the gentleman in the photo is not Babbage, but he's a type of historian, and we're going to watch this short video clip. It's about 4 minutes. And hopefully I don't have the commercial. No, always get the commercial. All right. As if we're finishing that up, uh, as I stated, Babbage, an amazing mathematician, and then he actually, a lot of people that worked under him became amazing programmers and others who helped push computers along. And here we go. Here's our video.
The engine behind me is Babbage's difference engine number 2, designed by Charles Babbage, an English mathematician who is also known as the first computer pioneer. Babbage designed this machine between 1847 and 1849. Babbage, as we know, did not succeed in completing any of his own engines in their entirety, so there is no complete Babbage engine. This is the first physical realization of any of Babbage's complete designs in the metal. The engine itself weighs 5 tons. It consists of 8,000 parts made of bronze, cast iron, and steel, and it measures 11 foot long and 8 foot high. It's operated by cranking a handle. What it does is it calculates and tabulates the value of any 7th-order polynomial, class of mathematical expressions, to 31 decimal places. It not only calculates that with unerring accuracy, it also prints an inked hard copy as a record of the results, and also produces what are called stereotype plates. That is, it impresses the results in soft material, plaster in this instance, so that you can make a printing plate automatically. Now, the purpose of all this was to eliminate the risk of human error in the calculation and production of printed mathematical tables. The machine is operated by cranking this handle. So you turn this handle, and each cycle of the engine, the machine produces one result. So you just keep cranking. You set the initial conditions up on the figure wheels, on the number of wheels. You turn the handle. What happens when you turn the handle is it drives this cam stack. And if you like, this is the microprogram. This is the device that orchestrates all the internal motions of the machine to get it to form the repeated additions that are needed for the method of differences, which is the principle it is using. So you turn the handle, it turns these cam stacks, the 28 separate cams, and that is what determines the internal timing and the orchestration of all the mechanical movements of the whole machine. So that's like the guts of the machine, the internal microprogram. What the machine does is it adds a 31-digit number on one column, and it progresses through the machine, adding from column to column to column, and the tabular value, the result, ends up in the very last column, 31 digits. So you crank the handle. Each cycle of the engine, that's 4 turns of the handle, each cycle of the engine produces the next result on this column. So the end process, the end product of that whole process is a 31-digit number on this column. So we take the 31-digit result from the end of the machine at the end of the cycle, and it is automatically transferred to this apparatus, which is the output apparatus. It does 2 things. It prints on hard copy, in inked hard copy, a 31-digit result. That's a checking copy, so that you know actually what you've calculated. At the same time, it impresses results on soft material in these trays. So inside there are things called stereotype punches, which are number wheels, which are lowered into the tray. The tray then moves, it lowers again, and so the lines build up. Firstly, it's on display here at the Computer History Museum for 1 year. It's on loan from the owner of the machine, which is Nathan Myhrvold, who commissioned the machine. He paid for the machine to be built. And so it's here for a year, and then it goes into his private collection. What we will do with it is demonstrate it for people. We'll work on it. It's a research machine, so it'll be adjusted and worked on. We'll get experience about how the thing operates. And also, part of the reason now that it is here and it does work, and we have for the first time a Babbage engine, the idea is to do some research and say, was it a practical proposition? If Babbage had one, could they have successfully produced tables? Babbage was not an impractical dreamer. This machine works as he intended to work. It was the entire enterprise of using the infallibility of machinery to produce printed tables. Was it realistic? Could it have been done? And for the first time in history, we were in a position to actually answer that question.
All right. So basically, he never actually created it, but it's a really cool invention that helped start what we consider computers. Now, the first programmer, Ada Lovelace, is considered the mother of programming. She was a gifted mathematician who was a student of Babbage. She worked under Babbage. She worked on the difference engine. She is credited with being the first programmer. The Ada programming language is actually named after her in her honor in the 1840s. So once again, a brilliant mathematician. The next is the data tabulation machine in the 1890s. Herman Hollerith. Once again, data tabulation, where we are looking at crunching numbers. So original, what we would consider the evolution of computers was for data purposes, was for numbers, expediting that process. Next. On our history of computing, a Turing machine was created by Alan Turing, a modern programming concepts. He did this in 1936. And one of the things that really pushed Alan Turing was the fact that as hardware evolved, so did programming. So as our hardware got better, our programmers were able to create more. Alan Turing developed a hypothetical Turing machine. He's considered the father of artificial intelligence. Now, in this example, a Turing machine can be adapted to simulate the logic of any computer algorithm, and is particularly useful in explaining the function of CPU inside a computer. Furthermore, Alan Turing proposed the Turing test, as we stated, consists of a blind judge asking a series of questions to a human and a computer. If he can't tell the computer from the computer passes the test. The computer is said to be intelligent. Now, this was the basics of artificial intelligence, and this is the reason he's considered the father of artificial intelligence. The fact is, now we have computers that are making logical decisions, as well as playing, for example, playing chess and making its decisions based off of what other humans are being. And artificial intelligence is becoming more and more advanced. Is it what we think of it now? No, but everything starts somewhere and it evolves as we get more and more advancements. Technology helps create advancements in technology. Next is John Vincent Atisov. Is considered to have created the first digital computer. And the reason we say digital computer, it was the first non-mechanical computer. Instead of being basically a machine, this is actually digitalized. But it didn't have a CPU and it wasn't programmable. But it did everything in a more electronic format. Okay? Now, Colossus. Colossus was the first digital programmable computer. It was used in World War II. It was used in World War II by the British to help with code breaking. When I talk about code breaking, I'm talking more about like secret messages. The British used it, and as well as Americans, but the British helped create it to break down messages to translate from that were intercepted from the Germans. And the computer was a massive series of racks and lights. And here's an image of that. Okay. Now, the electronic numerical integrator and calculator, otherwise known as the abbreviation of the ENIAC, was the first mainframe computer. And as you can see, it was massive. It was so huge. And it occupied a 20 by 40 foot room. Think about that. 20 by 40. That is just a massive room. It had 18,000 vacuum tubes, and it weighed 50 tons. 50 tons. £100,000. And to answer your question, Kate, they didn't always have screens. A lot of them basically would calculate numbers and give you like a printout. So what you think of what a computer is today, we're not even there yet. We're not even close to it yet. Okay. This was developed by J. Presper Eckert and John Munchley at the University of Pennsylvania in 1946. While, as I said, John Vincent Astoff built the first digital computer, many folks consider this to be the first truly digital computer in the U.S. because it's programmable, where Astoff was not programmable. Okay. Yeah, okay. All right. Now, as I stated, it had 18,000 vacuum tubes. We don't see these anymore, and we don't use them. A vacuum tube was a device that controls current through a sealed environment. Now, it often acts like a diode and was used as a switch. The thing is, we've replaced this with semiconductors and transistors. Due to the advancement of electronics, we've gotten rid of vacuum tubes. Vacuum tubes were big and bulky, and they limit the size of the advancement of making electronics smaller. We couldn't get smaller because of the vacuum tube, until semiconductors and transistors were invented and replaced this. So, due to that wonderful bit of technology, we've been able to make computers possible. The size and cost made computers expensive and massive when we have vacuum tubes. Now that we don't use vacuum tubes, and as you're starting to notice, computers are already they're bigger, they're massive, they're able to do more, they're becoming more digital in this evolutionary track that we're working up to today. Now, next stop on this is we're going to be looking at Rear Admiral Grace Hopper, the U.S. Navy's oldest active duty officer at the time of her retirement, and was the developer of the first compiler. A compiler changes symbols we can read to symbols that computer. Kind of basically, it puts it in computer language, but it translates it for us to read as in human language. Now, this is an amazing woman. A simply amazing woman. Brilliant. Admiral Hopper coined the terms computer bug and debugging. A fun fact is that other women who worked on computer and programming were often not named or seen in pictures because at the time, people would think that they were cleaning ladies and not professionals. So they would blatantly keep them out of photographs. That is just the way culture was at that time. The people around her, Katie, are other, at the time, programmers, engineers, etc., working on for the government. A little bit more about Grace Hopper. Besides developing the first compiler language, she's the developer of the UNIVAC-1, which was a mainframe computer. So she helped develop a mainframe computer, and also COBOL, programming language. COBOL is still used today. She created this programming language. Okay? Really impressive woman. Now, look at this quote here by Popular Science. Popular Science is still around. This is a quote by Popular Science in a 1950 issue. Computers in the future may weigh no more than 1.5 tons. Now, Popular Science may have been a little conservative in their predictions, since today we have wearable computers, and we have smartphones that are computers that weigh so little that we've come so far. Yes, Max. Wow. No, I don't, Katie. So it's really impressive. The thing is, we've come so far in the last 40 to 60 years with the advancement in computer technology. All right. And it's something to take in consideration. The next major invention that helped drive down the size and cost of computers was the integrated circuit or computer chip that was created in 1958 by Jack Kilby and Robert Noyce. When they created this chip, the chip drove down the size and cost of computing. So we now are, as I stated, have wearable computing. We have small, tiny computers. When the original computer costs were millions of dollars and took up rooms. The fact that we've been able to drive down the cost, make them smaller, make them more affordable to the mass public is just amazing. To look over the amount of time that we've been able to do it. It's just phenomenal. Next, Douglas Engelbart in 1964 developed the first mouse and graphical interface. The computer that you're using right now has a graphical interface. We take it for granted that pretty much all you need to do is point and click half the time. That you're interacting with a graphical interface. Old school computers, it was all lines and code. We didn't have the same purpose. That original purpose of being math oriented for analyzing data and calculating numbers changed. And as we keep evolving. Now, this mouse here is not the original mouse. Actually, it was much bigger than this. This is just a representation of even how much a mouse has changed. Okay. Next on our stop. I don't know. That's a good question. I don't know why it's called. That's a good. I might have to look that up. Katie asked, "Why is it called a mouse and it wasn't called a clicker?" That's a good point. The next is we're starting to move into what would we consider the foundations of the internet. The ARPANET logical map. This is an image from 1977. Is demonstrated in 1969. ARPANET is the forerunner of the internet, and it was created during like the nuclear Cold War, and a lot of it was to help pass information around. It was created because at the time computers were few in numbers. All right, computers were large, expensive, took up a ton of space, but people wanted to share resources, similar to what you all would consider cloud computing today, and all users sharing the huge, powerful server farms. This was the same concept. And if you look at this map, you can see that there's different cities, states, a lot of colleges on here, like Stanford, MIT, Harvard, Rutgers, NYU. The Pentagon is on here. And people would use it was a network of computers that access each other and use information. Okay. We still are all interconnected, but not as technical. information. And we'll see that. Another advancement is the DRAM chips that were created by Intel in 1970. These chips were dynamic random access memory chips. Now we're starting to get into memory. Because the memory chips of computers it was simplicity. It was very simple. The single transistor and capacitor helps computers become more powerful and cheaper. Now, once again, you see power, but power doesn't have to mean size. We want to get them smaller, and that's what you're going to start seeing here more and more. Now, the thing about this step in memory is that when the power's off, you lose whatever memory is there. Downside. So it has to always be on. Think about like if you've ever seen the older clocks that you plug in, alarm clocks, where they're great, but as soon as your power goes out, they shut off and like reset. And we have Taha with his hand raised. Yes, Taha, go ahead.
Unmuted.
Why is it called dynamic random access memory chip? Why is it called random?
I don't honestly know. There's probably a reason behind that. I can look into that for you.
Okay.
But it probably has something to do with the way it was formatted or created. But that's a great question. I'll look into that. Thank you, Todd. Max.
Having babies, there's nothing to stop them, except if he was adopted. Sometimes
Max, you're unmuted.
and nobody talked about it.
Okay, so I have something. I'm kind of guessing why it was called random.
Okay.
Maybe because you could just do anything you want on the computer, and it's like random, whatever you want to do, and it's just like a memory chip to remember random things.
All right. Yeah, that's a great reason. It makes sense too. All right. Thanks, Max. Glad your computer's working now.
Yeah.
All right. Now, we're moving into personal computers enter the market. And this happened in the mid-70s. This included TSR-80s, Altair, and Commodores. These computers, due to these advancements, start getting smaller, cheaper, etc. Now, a TSR-80, or affectionately called the Trash 80, was sold by Radio Shack and was hugely popular in the first year of its release. All right, so because of memory chips, because of the integrated chip, the semiconductors and transistors, we're getting smaller. We don't need to have massive mainframes. People are able. Now, the thing is, were these as powerful? Were mainframes still way better than these? Yes, but you can start seeing the transition. Here is an Apple II created by Jobs and Wozniak in 1977. All right, so Apple computers. Next, businesses. Businesses help make the major push that helped people get access to personal computers. Basically, in other words, due to the fact that spreadsheets, such as nowadays we call it Excel, and word processing, such as Microsoft Word, you had VisiCalc and WordStar were very useful to companies. They're excellent. Now you're starting to able to save. They made businesses function better. And these software applications came to the market in the late 70s. And what happened was businesses bought lots of computers, which drove down the price because now companies realize they have something that people want. And when they're selling a lot of them, they can mass produce them. When you do that, you can drive the price down, especially with all the advancements. Now, all of you need to be thanking businesses for doing this because that's the reason you can enjoy all your computer games. And eventually it hit the markets and home users were able to end up getting these because of them being cheaper. Here is an IBM PC from 1981. IBM PCs came into the market using Microsoft DOS. We still refer to DOS, and DOS stands for Disk Operating System. It is a huge success and established Microsoft as the operating system of choice. This creation of this collaboration between IBM making the physical hardware computers and Microsoft making the operating system is what made Bill Gates very, very rich, and the contract that he did with IBM put Microsoft on the map. Now, here's a Macintosh computer from 1984. I actually used one of these when I was a kid in elementary school. This is basically the grandparent of any Macs that anyone has. This was the first computer with a graphical interface. And instead of a line command code, such as in the IBM PC running on the Microsoft DOS, where you had to do more line coding, Apple started using an interface. And now everyone pretty much uses a graphical interface. Now, next, in the mid-'80s, personal computers are reaching mainframe performance, meaning that they're getting smaller, but they're becoming equally as efficient and fast as a mainframe, such as this Compaq 386 to the left is the first to introduce 32-bit architecture, which gives mainframe performance. So we didn't have to have these massive computers anymore. They're getting smaller and more personalized. Sam says his friend has one. That's awesome. Now, we're going to, HTML is created. That's what most websites are created in. It was created by Tim Berners-Lee in 1990, a Kern researcher. He developed HTML, which stands for Hypertext Markup Language, which fosters the creation of the World Wide Web. Also, as we know, as the WWW. Now, because of this, the ARPANET, as we talked about earlier, which is pretty much a connection between colleges and government agencies and other companies, is taken down and loses functionality. And eventually what we end up with is what we consider the internet today. Now, we're going to look at a quick clip about some computer history.
The first Univacs had the computing power of $10 digital watch. Yeah, it was really low.
Now they're classic dinosaurs, big, slow, and extinct. It wasn't until much later that World War II helped spawn the first true electronic digital computers. One of the earliest in America was the Electronic Numerical Integrator and Computer, better known as ENIAC. The ENIAC was designed to quickly figure firing tables for artillery pieces headed to war. ENIAC was huge. 100 feet long with a weight of 30 tons. It contained almost 70,000 resistors, 10,000 capacitors, and 6,000 switches. It could perform up to 5,000 additions, 357 multiplications, and 38 divisions every second. But ENIAC wasn't completed until 3 months after Japan surrendered. Nevertheless, ENIAC was a milestone. In 1951, the Remington Rand Company introduced the UNIVAC, the first computer to be sold commercially. It cost a mere $1 million for an entire setup. The UNIVAC was a much faster machine than ENIAC, but only used 5,000 vacuum tubes, as opposed to ENIAC's 19,000. Although the Pentagon, General Electric, and DuPont all used UNIVACs, computers were still too expensive for most businesses. In 1959, Robert Noyce and Jack Kilby, engineers for rival transistor manufacturers, independently came up with breakthroughs that led to the same revolutionary idea: an entire network of electronic components, transistors and all, incorporated onto a single chip of silicon. But what really made the computer a ubiquitous device was the advent of the microprocessor. Basically, an entire computer on a chip. Intel introduced the 4004 chip in 1971. The $200 chip delivered as much computing power as the ENIAC did in 1945. The 4004 opened the door to the personal computer revolution. As chip prices came down, a few inexpensive build-it-yourself computer kits started appearing on the market. The Altair was one of the early kits introduced in 1975. At $400 per kit instead of $25,000 for a commercial computer, the Altair generated a lot of interest.
This is an Altair 8800 computer, and to program it, you had to flip these switches 8 at a time relatively quickly in order to have it do what you wanted it to do. It was capable of running word processing programs and accounting programs. This was really the computer that started the personal computer revolution in the United States.
Obviously, the term computer-friendly would have to wait. But two guys from San Francisco wanted to change that. Steve Jobs sold his Volkswagen, and Stephen Wozniak sold his HP calculator to finance the Apple Company and introduced the Apple II computer in 1977. It was a plug-and-play device with no wires to solder. It was also reasonably priced at $1,200. The Apple II was a huge hit. Soon other companies introduced competing products. Hoping to take a big blue bite out of Apple's market share, IBM introduced their version of a personal computing device, simply known as the PC, in 1981. Today, microprocessors are in everything from refrigerators to Fords, watches to water sprinklers. They are the on-ramps to the information superhighway.
All right.
If shaving is a pain in the neck, cheek, or chin.
All right, we don't need to hear about shaving. Just some still frames. Just so far our computers have come, where we have these giant mainframes that are just massive, that we're using to take up whole rooms. Eventually, they just get smaller and better, and people just pushing and taking more advancements. This image is the Apple I. And computers just became more and more accessible in the 80s. Okay. and then having a just made things better and better and better. Okay. Now let's get back to this. All right. Now, by the 90s, we have graphical interfaces, personal computers becoming more and more common. Companies and businesses are using them regularly. And then we have the internet. The internet starts becoming very useful for searching information and shopping. Instead of using it for major technological uses like the ARPANET was, we have people buying stuff online. Okay. And then in the late 90s, 99 to be exact, Napster is born. I was in high school when this happened, and it was wild. Napster came out. Some guy created it. It was a sharing software, which now sharing softwares are so common. All of you have just grown up with them. The thing you got to worry about most is viruses or downloading stuff illegally. Now, Napster came out and it changed everything. Napster was started by high school dropouts, and the open source community began. That just sharing of information, sharing data, sharing resources. No one even thought twice about it at first. Napster was around before people started worrying about, wait a minute, no one paid for this music. And the thing is, Napster literally pushed even the changing of laws and what you can download and what you cannot, which was just wild. I literally remember having Napster on my computer, and then I remember Napster getting shut down, and then you had to pay for it. So yeah, I'm showing my age here, guys. Now, the iPod comes out in 2001, all right? And the thing is, this is a big deal for the Apple company because the iPod began the transformation of Apple from a computer company solely to a consumer technology company. The iPod becomes a huge hit and sets the standard for digital music. Now we're starting to download music online. We have digital libraries. Before this, most people were doing things primarily on CDs, just the way it was. And now there's so many different versions of MP3 players. You can get an MP3 player pretty cheap. Now, Sony has the PlayStation 2, comes out in 2001. And you had the PlayStation, then we had gaming devices, and these are computers from Nintendo all the way back to Atari, to Sega, Genesis, etc. Microsoft has the Xbox, and now they just came out with the Xbox One. But the thing that was important, the reason we're bringing up, these are computers. They're not what we think of a computer, but they're computers. These computers are manufactured to solely play games using cartridges and CDs, discs, etc. Now we're to the point we can just download them onto them. But while very popular because of the easy access for kids, whoever, there is no longer need to program the game or to even do command prompts to play a game, which helps produce multiple generations of people that are just passive computer users. We take it for granted that due to the graphical interface, due to the gaming era, that all we do is click and point. Computers are set up for us to be consumers. Originally, computers had more of a creator mentality. You had to learn something to get it to work. Okay? And this has changed. Yes, Max.
So I have something on the Apple stuff. It's kind of far back, and so I just finished a book on Steve Jobs.
Yes.
Where and I learned all about the Apple One, all about the Apple II, all the way through the iPad.
Yes.
And it was really interesting, and it just showed me so much more on how the computers work.
Mm-hmm.
It was really interesting.
Fantastic. Glad you read that. Very good. Thank you, Max. And now the main reason I bring up this user aspect of just plug and play, we're just pointing and clicking, and it'll make sense in a little bit. Now, literally 10 years ago, as of last week, Mark Zuckerberg, while attending Harvard in 2004, creates Facebook. Now, this transforms the internet. We soon in 2006, Twitter follows, and thus begins the age of social media. Social media, social networking is huge now. I mean, there are social organizations for just about everything that you can be part of, professional ones. Like I belong to LinkedIn. Maybe your parents do as well. Instead of and it changes the way businesses work and marketing agencies as well. So this is really changing. It's interesting. Okay. Also in 2006, Google Docs is released. And Google Docs is our first move. For many people, Google Docs is the first experience with cloud computing. This put cloud computing pretty much on the map. People become extremely aware of it, where I can save something out there that I don't have to have on a physical piece of hardware that I own, save to. And yes, Katie, your mom is correct. Zuckerberg made billions off of it, and he's still making tons of money. Facebook is just, when it first came out, you had to have like it was attached to colleges, and I was in college when it came out, and I remember my college got on the list that they were going to have Facebook access, and you had to register with a college email address, which was genius because eventually people graduate college and they transcend it into the rest of their life. And then when it went completely public, and they had a high school version for a while, and now it's just completely public, and it just has millions upon millions of people on it. It's crazy. Instagram's owned by Facebook. Instagram's making bank too. All right. Now, in 2007, Apple releases their iPhone. Now, the thing that's crazy about this is that it's not just a phone, it's a computer and a camera. People now, folks all over the world, carry a computer with them. Imagine, in less than 40 years, computers went from the size of a room to the size of a phone. And they're continually getting smaller. There are so many different types of smartphones. Google has a smartphone now. You have Android devices. It is wild. In that short amount of time. In 2010, the iPad is released. Now we have Amazon Kindles, Samsung tablets, Google has items coming out, and this has basically made computers get smaller and smaller. Without smartphone screen limitations, tablets are replacing desktops. And desktops, and I mean laptops replace desktops, and it's just getting the creation is becoming creative destruction, where things are creating and destroying other pieces of technology. I mean, it's an amazing time. And the thing is, we have to realize all these devices are computers. Computers play such a large role in everything now. I'm going to speed up a little bit so I can get to the last few bits of information. Now, along with this, a computer is an information management machine. It takes information, data, instructions, and management, storage, transfers, process. It has input and output, physical to digital, digital to physical converters. It has memory. It has a processor, okay? Now we have bits and bytes. Bits, these are the smallest units of information that can be stored or manipulated in a computer. This consists of zeros and ones, basically thinking as false or true, off or on, no or yes, so on. A bit is not just a small unit of information, but for sake of discussion, it can be said that a bit is also the largest unit of information a computer can manipulate. When we bunch these up, we get bytes, and now we're starting to look at binary code, which is like the foundation of coding based off of ones and zeros, okay? And a byte also has to be known as bits are needed to represent letters. So as you can see here, letters end up numbers, as we know it, are represented by groups of ones and zeros. All right, and I'm trying to speed up. And then with a CPU, this is our central our processing unit, our chip, our central processing unit that has made our computers what they are today. They are getting faster, faster, and faster, and this we have multi-processing capabilities, multi-process, multi-core processors, so on and so forth. Okay. And this is just wild. Okay. Ladies and gentlemen, this history of the computer has really changed what we are doing. It has pushed us forward further and further. To a point where, yes, Zach brought up Microsoft Surface. Yes, Max brought up the Bionic contact lens. We are getting technology that is wearable. We are getting technology that it's making Google Glass look like a dinosaur. Eventually, we're going to have contact lenses that we can wear in our eyes that basically have the internet on them. They're computers. So there's a lot of great things that are coming. And the thing is, I want you to realize technology helps produce new technology. Through advancements of technology, we'll create newer advancements in technology. We are further ahead in the computer age than predicted when all this started. So, ladies and gentlemen, we'll wrap some of this up next class, as well as we'll be moving into our Raspberry Pi units. Ladies and gentlemen, have a wonderful night, and as always, thank you for being part of Young Engineers of Today, and take care. Bye-bye, everyone.